Well, yes, I think it's been fun to talk a little bit about magic squares. And magic squares have fascinated mathematicians and artists as well for hundreds of years. And I'd like to show you just a print. It's called Melancholia 1 by a German artist. And in this you can see a rather plump melancholy angel with various mathematical devices. She's holding a pair of compasses in her hand. There's this complex geometrical object here. There's a sphere down here, and then various tools and objects. And also we can see a wonderful comet and a rainbow. Time is passing. And up in the top right-hand corner, we have a magic square. And if we zoom in on this, it's written in sort of slightly old-fashioned symbols, but somewhere. Okay, so this is written out in modern versions of the numerals, the magic square that appears in Dürer's painting of Melancholia 1. And if you look at this, you'll see that all of the rows, so this row, if you add those numbers up, 16 plus 3 plus 2 plus 13 adds up to 34. And if we look down this column here, 3 plus 10 plus 6 plus 15, that adds up to 34. And then if we look along the diagonal, if I remember correctly, that's 26. And then that's also 34. And this diagonal is also 34. And we've got a 4x4 square here, notice, and we've used the first 16 numbers to fill that square. That's your typical magic square. Now, this one really fascinates me. I've got it hanging up at home, and I was looking at it one day, only a couple of weeks ago, in fact, and I discovered something on it that I've never seen before, and I've looked around on Wikipedia and not seen any reference to it. But if you add all the numbers in Melancholia, so if you add all the numbers of the magic square, and we've seen that each of the 4 columns has 34, so if we take 4 times 34, we get 136. And then if we look for one more number in Melancholia, it's called Melancholia 1. And if I add 1 to 136, I get 137.
Oh,
and this is approximately equal to 1 upon alpha, my friend, the fine structure constant, which tells us the ratio of the strength of the electrical force to the quantum.
Are you suggesting there's some meaning or something?
No, it's purely coincidence. But well, I think it's purely coincidence, but I think it's very funny, and it's not very widely known. So I'd be great if we can put it into 60 symbols and do word squares. Yeah, I mean, I've been fascinated with these things since I've been a kid, and I played around seeing if I could make them, and I started off with a nice, simple, odd 3x3 number square, and I wanted to try and make all the rows and columns add up. And I think the rather plump angel here just looks like a physicist, and she's obviously worried about infinities or integer numbers or the volume of this and thinking about spheres, or maybe she's seen this comet on the rainbow wondering about it. It's just a delight to a physicist to see it. So I find she looks very patient, just thinking away the problems, and that's what we have to do. And when we get a bit melancholic and depressed, we have to press on with our calculations and do our experiments. So I find it just inspiring.